Now, let's talk about the measurement chapter, physical quantities, units, and measurement itself. Now, so in upper sec, we are going to split our sciences into the three different chemistry, physics, and bio. So physics actually come from the word physical. So physical things are all things that we can see, smell, touch, and hear, and more specifically, physical quantities. So they're all quantities that can be measured. So you should have a number, which is our magnitude, and a unit itself to represent it. So you can see over here, this is your length, physical quantity, unit, and magnitude. So I'm going to use different colors to color code it, so at least you know which is which. Okay, so length will have a number and then a unit at the back. So let's talk about base quantities. So what are base quantities? Base quantities are your basic physical quantities. Every other quantities itself are basically a combination of this seven itself. So we call them derived quantity. So one of the more common quantities will be speed. Speed is distance over time. So you'll notice that distance is just your length and divide by time. So you can see it's actually just a combination of your length and your time, which are both base quantities. Okay, so base quantities over here are what we are more familiar with. You have your mass, your length, your time, and your temperature itself. So these are all something that is all very, very familiar to us. Then for your amount of substance, this is actually in chemistry. Your number of moles, luminous intensity, this one is basically outside your syllabus. This one is usually for university or in JC itself. And if you see this current down here, this is for electricity. So we won't touch on this until we reach set 4. Okay? So your mass, length, time, and temperature, these are all things that we have learned before and used before in lower secondary. One thing to note for your mass, you will notice that for your mass itself is the only one that has an additional symbol in front of it. This symbol is later what we will know as your prefixes. Okay, so before we move on to the prefixes and standard form, let's talk about the rest of your quantities. So SI units. Now, SI units are basically units that everyone will actually agree on. So whether they are working in America, whether they are working in Singapore or China or whatsoever, all scientists will all agree to use these units in all of their research papers and everything, because these are basically the standards. Now, for kilogram, meter, seconds, all of these are things that is all very, very familiar to us. But the moment we reach temperature, normally in Singapore, we use degrees Celsius. And in America and other countries, they use degree Fahrenheit. So to prevent conflicts between the different parties, both of them all agree to use kelvins, which is another unit for temperature. Okay, so all of these are basically your basic quantities. Every other units are all basically just a combination of all of these quantities that we have over here. So prefixes, if you look at the English itself, pre means before. Prefixes, so before the unit itself. So before the unit, so you see all of this, such as N, micro, C, deci, kilo, mega, giga, tera. All of these are prefixes before the units, the symbol before the units. And what exactly are they? They are basically just your multiplier on this side. So this times 10 to the power something times 10 to the power something, they are the same as the letter N, micro, and so on and so forth. So let's go down the list and we try to identify which is which. Now, one thing you will note is that all of these are small letters, correct? So small letter is usually negative. So you can see that the power here, they are all negative power, negative power, negative power. The only exception will be kilo, where kilo is a positive 3. For the rest, if you notice, mega, giga, tera, they are all capital letters. They are all positive numbers. And if you notice, they are in multiples of 3. -3, -6, -9. And then for the middle two is -1 and -2. They don't have a +2, +1. So 1 and 2 will always be a negative number. So one way you can remember it as is this. N for 9. Here I use a different color to show it. N for 9. Micro looks like a weird M, so micro. Okay, so you can think of it as it's a weird looking M is a million. So million is 10 to the power of 6. Milli and centi is numbers that we are very, very used to. Can always just try think about it. 1 liter is 1000 milliliter. So it's 10 to the power of 3. And this is 10 to the power of minus 3. Okay, centi is 1 meter is 100 cm. So centi is 10 to the power of 2. But this is a small letter, so a minus 2. Deci itself is a bit special. Some schools do teach it in lower sec, some schools don't. Deci just means 10 to the power of minus 1. Okay, so you can think of it as 1 decade is 10 years, so 10 is 10 to the power of 1. It's a small letter, it's 10 to the power of minus 1. Kilo itself, if you forget what's kilo, you can always go back to 1 kilometers, 1000 meter itself. Okay, then mega, giga, tera. If you are more familiar with technology itself, megabyte, gigabyte, terabyte, you notice that it will actually increase in number bigger and bigger. So this one you can think of it as million. So giga is bigger than that, tera is even bigger than that. So I'm not sure if you notice, but the units at the back, whether you have your prefixes here, M, L, the units at the back, they don't actually matter. It could be whatever unit you see here, it could be, can be MM, can be MS, can be MA, can be MK, and so on and so forth. Basically, all of these symbols before your units are just your multipliers that cause you to either increase or decrease. So let's take, for example, let's use the one that we are more familiar with. Let's say 20 cm. Now, when we want to convert from cm to meters itself, can you see that this prefix is on this side that you have? So you have the prefix, we will multiply by the number itself. So this times 10 to the power minus 2, this is actually the same as your centi over here. So if you have the prefix, we just times 10 to the power minus 2. And in reverse, if you don't have it, let's say you have 20 meters. You don't have the prefix on this side. So you don't have, we will divide instead. So divide by a negative 2. Okay, so if you divide, you'll notice that your number will actually be the same. It will actually be bigger. So you have 2000 cm, for example. Okay, do take note about this. So if you have the prefix, you multiply. You don't have the prefix, you will divide instead. Okay, so do your best to just take down this, the power, the order of magnitude itself, how big, how small is it? So try your best, go back home, try to do this table yourself up. You can always do it in the flashcard. You can always test yourself. Grab your parents to ask them, oh, nano, what's the power? Oh, centi, what's the power? And so on and so forth. Okay. Then we have another way of expressing your physical quantities, which is your standard form itself. Now, you might have learned this in math itself. So, for example, over here, if you have 300 million meters per second, we'll actually note that the decimal place is over here. So you 1, 2, 3, 4, 5, 6, 7, 8. So you can see that you jump 8 times to the left, so we have a plus 8. So jump left equals positive power. If you jump to the right, it'll be the opposite. If you jump to the right, it'll be a negative power. So example would be, for example, let's say you have 0.02 millimeters and we want to change it to standard form. So you see this decimal over here, 1, 2. You want to express it at 2.00 times 10 to the power. Because you jump 2 times to the right, it will be a negative 2 mm. So your first number over here, your single digit, must be a non-zero digit. It cannot be 11, it cannot be 12, and so on and so forth. What I mean by that is, for example, 11.2 meters. You have to change it to a single number. So this becomes 1.12 times 10 to the power 1 meters. So sometimes when you're not too sure about your unit convert or your standard form conversion, just use your calculator. When you do your conversion, press this in your calculator. Do you get the same number on your left-hand side? If you do, that is correct. Okay, so do take note about this. The reason why we need prefixes and standard form itself is because when you move up to in real life itself, sometimes you deal with numbers that are very, very big. You have a lot of zeros all the way behind, like this one over here, 300 million meters per second. It can even be bigger, or it can be very, very small, 0.000 something. So because of this, you don't want to write so many zeros where it gets a little bit confusing, especially for students whose handwriting are not the best. So because of that, you can actually express your answers in standard form or in your prefixes, using your prefixes so that the numbers are not so crazy. So when you actually show all your numbers in your calculations, it will not be as bad as you think. Now, let's take a look at the word example over here. So for example, over here, you have your prefix and your standard form. So convert the units from one form to the other. You notice over here, you don't have the prefix on this side. So if you don't have the prefix, 1, 2, 3. Now you see, normally when you have a lot of numbers, you try to space them out as much as you can. So milli is -3. So you will have 0.095. You can always press your calculator, you will get 0.095 milligrams. Okay, so you don't have the prefix, I divide by 10 to the power -3 based on this milli over here. I end up with this number. Okay, so next, you see that you have a prefix here and a prefix here, right? So my recommendation to you is change to meters first. Let's do it step by step. Once you're more proficient, then you can actually combine it. So for now, 1, 2, 3, 1, 2. So you have the prefix, so we'll times 10 to the power -1. So you end up with 0.1231273 meters. Okay. So now from meters, you want to change to micrometer. You'll notice that you don't have the prefix anymore. So 1231273. We don't have the prefix. We divide by 10 to the power. Micro is -6. So you press this in the calculator itself. You end up with 7.3 micrometer. Okay. Don't just blindly just take this down. Do press on your calculator to double check, because during exam itself, there's no one to show you all the steps directly to the final answer. So always press your calculator itself, double check. Use brackets if you need to, so that you don't make any kind of careless mistakes. And just do double check as well. Okay. Next, let's talk about your standard form over here. So first thing, you will want to change from milliseconds to seconds first before you do your standard form. So what you can do is 0.45. You have the prefix, we multiply -3 seconds. So you actually end up with 1, 2, 3, 4, 5 seconds. So you will just jump 1, 2, 3, 4. So you jump 4 times, you end up with 4.5 times, because you're jumping to the right, -4 seconds. Okay, so just do a quick check. Yes, the numbers are correct. And then next one, same thing. When you have two different units itself, you can always just do your calculator and double check. 0.036 nano. So we have the prefix, 0 times -9 over here. Now, if you press this in your calculator itself, you'll notice that the numbers are way too long and way too small itself. So your calculator actually helps you change it into standard form already. So this is your amperes. Like I said, the unit at the back doesn't actually matter. So now, if you notice, you don't have the prefix anymore. So because of this, you want to divide. Okay, so I'll just write it on the next line. 3.6 times 10 to the power -11. You don't have, you divide 10 to the power -3. When you press this in your calculator itself, you will end up with a very, very, very small number itself. So you have 0.123, 123, 136. Yes, so this is your milliamperes. So we need to jump 1, 2, 3, 4, 5, 6, 7, 8. So you have to jump 8 times. So we are jumping towards the right, 3.6 times 10 to the power -8 milliamperes. Okay. Just a quick check if the numbers are right. Yes. So with that, we have done your standard form, we have done your unit conversions. So let's take a look at this next. What's so special about this field is that you have your cube and you have a fraction that you have over here. So let's try to do your cube first. So whenever you are dealing with area and volume, or whatever, whichever quantity that has a cube and a square. Let's do it bit by bit first. So 123.0081. Because we are dealing with cm and mm, let's change it to meters cube first. So we have the prefix, we'll multiply by -2. But because of the cube itself, we're gonna cube the multiplier over here. Because the reason for this is because if you take 1 cm cube, is equals to 1 cm times 1 cm times 1 cm. So if you were to convert each and every one of them, it's actually 1 times 10 to the power of -2, 1 times 10 to the power of -2, and 1 times 10 to the power of -2. Right? So you end up with 10 to the power of -2 cubed. So this one is just a shortcut. So whenever you have a square and cube, your multiplier, your 10 to the power of something, bracket the whole thing, and then you cube it as well. So when you press this in your calculator, you should end up with a very, very small number, which is so small that your calculator will help you adjust it. Okay? So just do take note, the number in front, the 0.00 something, is outside the bracket. It's not within the bracket itself. Okay? And next step, 10 to the power of -12 meter cube. We don't have the prefix on this side, right? So you will have to divide. So if you need to, put your brackets so you know that it's different. -3, close the bracket, you cube it. Press this in your calculator itself, 10 to the power of -3, and the whole thing will have to cube. You end up with 0.0081 mm cube. Okay, so a lot of steps. Just take note of your cube up here, cube up here. Okay, for your multipliers. Now, for your fractions, for this kind of cm per second and so on and so forth. Now, your 0.25 cm per second, you can actually write it as a fraction. This slash just means this divide sign. So 0.25 is just 0.25 divided by 1, right? Makes sense? So change bit by bit. So do your numerator first. From your cm, that's kilometers, right? It's too fast. Let's jump it to meters first. We times 10 to the power of -2. And below here, your 1 second. If you want to change it to hours or minutes, let's change it to minutes first. You divide by 60 seconds. Okay, so next. 0.25 and 10 to the power of -2. This is in meters, right? So you want to change it to kilometers. You don't have it, we divide by 10 to the power of 3. Same thing, from minutes to hours, you divide by another 60. So when you actually press this in your calculator itself, you end up with you end up with 0.009 kilometers per hour. Okay, so do take note of all the brackets itself, especially this part. Now try your best to use this format in your calculator, so you know all your numerators are on top, all your denominators are below. They try not to combine them at a certain point. Just try to convert bit by bit, cm, meters, km, seconds, minutes, hours. Just do your conversions separately. Okay, you should be able to solve for the final answer.